We've gone through the classroom part of the instruction. We'll come out into the field and take a look at some of the installations here. The first pump we're going to look at will wind up being as a horizontal split case pump. It's electric driven. This particular installation uses a water storage tank. This does not have any city water connected to it. We talked about the supply valve going into the horizontal split case pumps. Winds up being an OS&Y valve. If we take a look at the suction piping, is galvanized. It's like the code calls for. We get into the suction pipe. We talked about using because of the difference in size of the suction flange and the water supply, we're winding up using an eccentric reducer. It's a 6x5 eccentric. The flat part is up on top, tapered part's the bottom. The gauge that winds up being used on the suction side, because there's a possibility for this to go into negative head, is what we call a compound gauge, compound and discharge and vacuum gauge. We get over to the packing drains. We talked about that, coming down, tying these together, and then draining down into the floor sink. Going over up in the top of the volute or the top of the casing, winds up with an air release. You use a little return bend, so when the water is turned on, the air that's evacuated out of it won't blow up into your face. Coming on to the discharge side, here's our circulation relief valve. This is wind up being used to cool the pump itself down, nothing else. So, and it's going up to an unknown location, so we wind up with a sight glass to make sure that this can be seen when the pump is up and running, to make sure there is water flowing out of that. Coming to the discharge side, we wind up with our discharge gauge. It's different than the compound gauge on the suction side. We've increased the size up out of the discharge side of the pump. Coming to our discharge check valve. You can take a look at out of the bottom, and this is on the system side. We're taking our sensing line out of that and up, and it runs over to the control panel. This is our discharge. This is winds up going to our pump test header. This one in particular has a flow meter on it. It's going to come up to save water, take it back up, and recirculate it back to the tank. They also have a connection to show you the two different types with the flow meter in here, and then also this upper pipe runs over and takes it out to the outside where there's a pump test header that will wind up flowing. Then we come in over to the system shutoff valve, and then it winds up going into the system itself. A little bit different type of pump. We're going to a diesel-driven horizontal split case pump. We're coming through the same suction line, galvanized, because we're less than 50 feet away, OS&Y. Coming through the suction line. Should be gauges here. Same air release. We're doing the packing drains. The packing on this type of pump is supposed to allow water to drip continuously through it, whether it's running or not. So it has a small drip coming out of it. We've taken these, tied these together, and then run them back over to a floor sink where that water can be recouped and put back into the tank. Because this is a variable speed driver, it's diesel driven. As we get to the discharge side of the pump, this is where the semblance somewhat changes. We're going to upsize the piping size. Because this is a variable speed driver, diesel driven, we're going to be required to have a relief valve on it. And what this one is used to, if the engine goes into overspeed and causes the pressure to raise up, it will wind up opening the relief valve up. It has a sight cone to make sure that water is running through there, because when it originally is running at at the regular speed, there should be about a thumb's full of water coming out of there, and that increases the pipe size, but it has a sight glass in it to be able to see if there is water moving through it. This is going to be taken up and put back into the tank to wind up saving water. Continuing on into the discharge side, the discharge check valve that's right up here, the same sensing line setup that goes over to the control panel, wind up through the discharge shutoff valve. Go on into some of the parts of the engine. On the discharge side of the pump, we're taking our engine cooling water. It comes through here, goes through the cooling loop, comes back in, and this is what we call the raw water system. And what that's going to do is cool the contained system that has the 50% water and 50% coolant mix inside there. So it runs through a strainer, it runs through a regulator, and it runs through a solenoid that keeps it shut off. So this water will not be recirculating until the control panel calls for this pump to fire. This solenoid will open up and allow the water to run through it. We talked about going up through the raw water. This is the water that cools the water that's contained in the system. It is wind up needing a sight glass because we can't see where it's discharging to. It's rising up. They have done exactly what the code book says because of the distance and the elevation. They've increased in pipe size. Coming over to the fuel system, this is part of the fuel return. It comes over in through the fuel vent, which terminates, the code calls for 10 feet higher than the red fill cap. The fuel vent continues to the outside of the building and then up. And if you take a look, this is a dual wall tank, so the fuel spill is on the outside part of the tank. The vent goes up and out of the outside part of the tank. There is a local fuel level that's here. There also is a low fuel alarm that would wind up going back to the control panel here. This is the fuel supply. It's set at the same elevation as the fuel pump on the engine. It drops down onto the floor, runs over to the flexible flame-proof connectors. And we can go ahead and get to the batteries. We can see where this is a dual cranking system with only 2 batteries in it. It's a 12-volt start. You can see one set of battery cables goes over to one starter on the other side. The other set of battery cables comes up to starter number 1 on this side. And that's what gives it the dual cranking system. You can see where the black cable is grounded onto the frame itself or onto the engine, and the other one is going up to the starter motor itself. Moving on to the exhaust, is covered by protection to make sure that nobody gets burnt. The flexible connector that's on the discharge side of the engine is right here. Continues on up to the wider part where the muffler is located. You can see the condensate drain that comes out of the bottom of the muffler, and then it continues out and up through the roof. Coming off to the discharge side of the pump before the system control valve, we're going to rise up, run it back through a flow meter that will wind up ultimately going back into the tank to save water, rising up, upsizing because of the distance back, and dropping down and going out to the pump test header to be able to test the fire pumps. The water storage tank is showing the level of it. It winds up with almost 11 feet of water in there now. That's a manual indicating, so it's connected to a float inside the tank. Going over to the jockey pump, it's taking suction out of the water storage tank again. Comes down through the indicating shutoff valve, brings up, going up through the vertical turbine type, which you can see that standing up straight up. You notice the housekeeping pad has raised up to wind up making sure that all of the electrical parts are at least 1 foot up off the finished floor. Comes through the discharge side to a check valve, comes over to the outlet for the sensing line that goes up into the control panel. Comes the indicating shut-off valve, so if anything happens with the pressure switch inside the panel, we can shut the water off here, shut the water off there, and wind up doing whatever replacement we have to do in there. You can take a look at the drop leg for the sensing line. Winds up with a globe valve shut off, our line to screw in the gauge to be able to do set our start and stop points. Wind up with a second shut off valve, and then it continues on up and goes into the system. We're out in the shop now. We're going to show setting the vertical turbine and with a diesel driver. There's a little more to this than there is with a horizontal split case pump. Because we're dictated with the hole in the water storage tank, we want to go ahead and there's no way that we can move the pump. We need to set the driver correctly so we can use the drive line that fits in between the two of them. When we're getting ready to set the distance between the engine and the pump itself, we want to go ahead and open the drive line up and then close it down and then split the difference in between that to make sure that when we set that, any kind of drill anchors or anything like that, that we have enough space in between that the drive line will work. We want to make sure that we take a dimension on that. We're opening the drive line to its widest position and take that dimension, and then closing it down, and then take that dimension, and then split the difference in between that so we know for sure that the drive line will fit. So we need to make sure we have this spacing correctly. Then, once we've done that, then we're going to make sure that we're square with the right angle gear head and with the pump itself or the driver itself. So if we go ahead and go off the face of this and the face of that, and then these two are parallel with each other, then we know that we're sitting squared with it. And then we need to check the distance in between. And if either of these are a preset anchorage and or you're going to drill these in later, that's the way we need to have the thing set. This is a right angle gear head. It has an anti-reverse ratchet, so it will only turn one way. We talked in the classroom about cleaning out with the file, about cleaning the keyway out and then making a mark up on top where that's the nut is going to be set. We're going to take the top shaft, which is stainless steel. This has a left-handed thread down at the bottom. The top part of it is a right-handed thread. So we're going to go ahead and drop this down through the hole. This would be the same way if this is an electric motor also. You want to be very careful. These shafts are heavy, and when it gets down towards the bottom, you wind up pinching yourself. So we talked about the coupling has a centering hole in that. So as if we go ahead and set this before we set the right angle gear head or the electric motor, makes it a lot easier. If you don't, you can screw this either up or down and poke a wire in the centering hole and make sure that you got it in the midpoint. Once we've done that, remember this is a left-handed thread, so we're going to wind up screwing that down, and what it's doing is screwing itself into that coupling that's there. This can be kind of it's a very, very thin thread, so it's going to take a little bit of while to get that screwed down. we're going to wind up needing either a strap wrench if you have one. If not, I don't like doing this, but sometimes it's the only way that you can do that, is to get a holdback in underneath where the coupling is, and then taking a pipe wrench and just pulling this snug to make sure that we've taken all of the slack out of that. And we're going to rotate this until we line up the keyway. We've made our mark where any one of the screw holes are. We've cleaned the key up. It's a hook-shaped key. We're going to go ahead and drop that down in there. Once we've done that, we're going to go ahead and take the top nut, and these are somewhat various. Some will have numerous holes in them. This particular one has just a single one. This is a right-handed thread again. Once this touches the bottom, then we want to go ahead and take the measure this, and we're going to lift this approximately 1/8 of an inch. As we're raising this nut up, what we're doing is we're lifting the impellers up off of where they're sitting. There can be anywhere from a small screw to small hex-headed. Once that we line up with that, we've got the hole there. We'll use the screw here, and all that's doing is holding the nut in place. To hold the nut in place so we don't lose our adjustment on the lateral, you can either wind up with this particular one has a single screw that holds it, and that's the reason that we marked that to locate that as we lifted it, and just run this up snug, and all it does is keep the nut from rotating. Once we've lifted this up, we've raised all of the impellers up off the bottom, and we've completed our work. This can remain. If it's electric driven, we need to take the nut, screw, and the key out to make sure that will spin properly. Once this has been done, then we can go ahead and put the drive line in. On the top of the top shaft, when they turn these, they leave a little dip in there. And what happens if most of the covers that are on here have a small hole up in the top, and when this fits over the top, you can, the pump guys or any of the sprinkler fitters can put their tack, if they have a manual reading tack, and put it into there, and that will read what the actual pump itself is turning. And then not all of the right angle gear heads will have a heat exchanger on them. We need to cut a T in downstream of the pressure regulator that's on here, so we don't get the real high PSI on that heat exchanger. Cut the T in, bring the feed back in to the underneath side of the heat exchanger. It comes up through here, and then this is the discharge, and we'll just dump it right back down into the tank. The heat exchanger is kind of a split affair that has a place for the water to come up through it, and what it does is it cools the oil that's inside the right angle gear head. On a vertical turbine, we do need to get rid of the air, so we're going to have an air release on it. It's going to be somewhat larger than the ones on the horizontal split case pump, which is like this one right here. It's on a 1/2 inch outlet. We don't need to evacuate quite as much air because when this pump is at rest, there is only water pressure up against the check valve here. The rest of this down into the water storage tank the column is going to be full of air. So when the fire pump starts up and we need to evacuate whatever the water level is there up to the check valve, we need to get rid of that air as fast as we can. So this is normally furnished by the pump supplier. As this is piped in, it's an 1.5 inch check valve. This is per NFPA 20. We want to not have this fully vertical, but up past a 45. So we want to have that swing check hanging open a little bit. That way there, as it starts up, the air is evacuated till the water hits the check valve and then slams it shut, and we're up and running.